Started here, right? It's 7 minutes past. I'm not quite sure why they haven't closed the door yet. All right. I'm going to go for the typical preliminaries when it comes to presentation. Who's had a long day? Yes, and it seems to me that I'm the last thing that stands between you and a beer, which is well-deserved, of course. So we'll cut a deal with you. Flex those neurons for another 45 minutes, and I think we can get through our material in that much time, and you'll still get all the information about this brave new world called software-defined networking, and which we also call here Cisco One Software-Defined Networking Evolution. I wonder a little bit if it's people that are SDN experts, and they're curious about the title, because their question is like, what? SDN is already evolving? I thought it was a revolution. Or whether it's people that really realize it's an introductory session into SDN and an introductory overview into the vast capabilities of Cisco's open network environment vision. My name is Paul Liesenberg. I work in the Network Operating Systems Technology Group, your friendly providers of NXOS, iOS, and iOS XR. We're about 2,500 engineers in the team writing software. It sounds like software to me, software-defined networking. Hasn't it always been about software? We'll ask ourselves that question in a couple of slides. And I'm assisted by the very able Omar Sultan as a question manager, and he'll also jump in. He has awesome expertise in data center areas, so when a question in that area comes in, then probably I'll hook him in to answer, so he has something to do other than looking at an empty screen. Let's talk about software-defined networking. First of all, let's take a look at the agenda we have here. Again, it's introductory, and the first thing I can say about SDN is that indeed it's growing. Its definition is changing. There is a core definition of SDN, but the core definition of SDN, can you really do all that much with it? If you want to solve real issues right now, if you want to fulfill SDN's potential, you have to extend its meaning somewhat. And everybody is doing that in the industry. Everybody attacking SDN, unless they have a very narrow focus and they're betting on the future and they have good financing, of course, to last another 2-3 years. Everybody's actually extending the definition of SDN to make it more practical and to have it be able to attack today's issues as well. There are also constantly new items that come into the SDN umbrella. So I think that the notion that one single person can be an SDN expert in every area that is hot right now is actually a thing of the past. There are too many areas out there with new things emerging, such as network function virtualization and I2RS and PCE and 100 acronyms. No one is actually 100% expert, and we're not going to be touching on all of this. People in this audience tend to be experts in one or more areas that we're touching, so don't get frustrated if I simplify a little bit as I plow through the early slides to present some basic SDN concepts and technologies that get thrown around in the SDN discussion. And then we'll talk about the Cisco Open Network Environment, what it actually is. And we'll spend quite a bit of time talking and probably discussing the concept of network programmability, because I think that's what's going to touch your life as network engineers the soonest when it comes to SDN. And also, if you were to get an OpenFlow controller and OpenFlow switch, any of you playing with that already? Curious. Well, there you go. Wow, you should be giving this presentation then. Because I think that's easy, right? If you have an OpenFlow controller, you guys read manuals, you know what to do with it, you play with it. But with programmability, it's a little bit of a new concept in networking. So we'll spend some time talking about it, because programmability is what really allows you to make the network relevant to applications. Now we spent a lot of time on this slide. Let's catch up a little bit. What are things that we define as SDN? The most fundamental one, this is the router or the switch, as you've come to love it over time. Integrated control and forwarding plane, a proprietary interface, very closely linked together so that they can work closely together to provide you with that very reliable, very survivable, very solid, very fair infrastructure that not only have you come to expect, but that your core constituencies probably are expecting you to provide all the time. Now, there are some new problems that are actually making, in some areas, the networking, the traditional network definition burst a little bit at the seams. And the promise in the industry is that we'll solve it by separating that control plane from the forwarding plane. This concept is not fundamentally new. I remember coming into the industry writing software for Signaling System 7 for a protocol called TCAP, and you had something called a service control point and something called a service switching point. Then I moved on to ATM, where again, switches just had a local notion of connectivity. They didn't have the end-to-end notion at all. Switches were just designed to be reliable and to switch from one port to the next. Done. So very similar in concept to what we're trying to accomplish here with software-defined networking. It's not a revolution if this is all it is. If you listen to the founders of software-defined networking, and another aspect of this is because you separate the two planes, there's always the discussion of commoditization of networking coming in. Hey, no, this is a commercial CPU. This is actually some merchant silicon, works together, so cost is going to go down a lot. SDN is about that, right? If you listen to the founders of SDN and call them present, and I urge you to watch a fantastic presentation on YouTube by Scott Shanker from the University of Berkeley, he doesn't talk about commoditization at all. He even doesn't talk all that much about OpenFlow as a protocol. He talks about the fact that networking, what it needs, is new abstractions that enrich applications. And that's what he promises, that by rewriting parts of the control plane, we'll start integrating more software engineering and better abstraction layers into networking as well, so we can better serve the needs of varied applications. I mentioned OpenFlow already. Once you've separated the control and the forwarding plane, OpenFlow is a protocol defined by the Open Networking Foundation, and it defines basically the communication between a controller and a forwarding engine. And more specifically, it's simply about the ability of the controller to write forwarding tables on the forwarding element, which means that these forwarding elements have no notion of network topology whatsoever. They only get told by the controller, you switch from this port to this port, and you switch from this port to this port. And that way the controller creates an end-to-end connection. Again, not a fundamentally revolutionary concept. We've done that before quite a few times in networking. It's interesting to see how some of these design patterns, as they call them in software engineering, how they reemerge cyclically in the industry. And what about the northbound interface? What about control protocols, you may ask yourselves? The Open Networking Foundation is not concerned about that at all. The idea fundamentally is that people will start to experiment with OpenFlow here, and we'll start writing software and new and innovative control architectures that somehow magically deliver on new functionality. Let's move on to the next hot topic in networking, which is virtual overlay networks. And we know that virtualization is not a trend. Virtualization is a huge scalability issue that exists out there. And if you think about the scalability issues that cloud providers are facing, you need to do something about networking. Because think about it. You have that virtual compute element, you have virtual storage, and if you go and you have millions of those devices, do you really want to connect them directly to your physical switches? You could assign them a real address, or you could put them into a VLAN, but then how do you actually cater to the mobile, fast nature of those machines? People want to be able to spin them up and down, to move them around, to change capacities all the time. That's not easy to accomplish if you fix anything in that architecture. So with virtual overlays, the idea is, but what you need with these virtual compute elements and storage elements, you definitely need layer 2 adjacency. And you want that layer 2 adjacency to be extremely flexible, so you can move these around across different layer 3 domains anywhere, and they still see each other as being in the same layer 2 domain. And you do that with virtual overlay networks. So basically what you do is, what we always do in networking, we tunnel. You go and create these, every tenant in the multi-tenant architecture gets a VLAN or VXLAN for extra scalability, and then you tunnel across the physical infrastructure, which means that whatever you change at that virtual layer, including the switches, no longer affects the physical topology of your network at all. It all changes around you constantly. And the physical network has no notions that virtual switches, because now you add this virtual switch to the virtual compute and to the virtual storage element. That threesome actually just, you can move it around very elegantly with these architectures. And also with VXLAN as a protocol, you are able to overcome the limitation of 4,000 VLANs in the traditional header. VXLAN gives you 16 million, which suffices for even very large data centers. Any questions about OpenFlow or overlay networks? Well, let's move on. Once you have millions and millions of these virtual entities that you can assign to your multiple tenants in a data center, you don't want to provision them manually, I bet that. So what you do is you look into orchestration frameworks. OpenStack is an open source project called the Cloud Operating System open source project. And what it does is it gives you an orchestration that it very elegantly allows you to arrange and control these virtualized compute, storage, and switch devices across your infrastructure. So this is what it is. They have different dedicated names: Nova for the compute element, Switch for the store element, and very near and dear to our heart is the Quantum service, because the Quantum service is the one that orchestrates these virtual overlays in the data center. Anything we should add here, Omar? So it's OpenStack, very important tool for orchestration going forward. We single out OpenStack because, of course, we have an agent for it at this point in time that we're showing in the world of solutions. But there are similar solutions as well, like CloudStack, and there are a couple of others. There are vendor-specific solutions that extend OpenStack as well. So by no means am I implying that's the only orchestration game in town. But an incredibly critical component in the puzzle. Now let's talk about the Cisco open network environment and some of the philosophical elements, why we did what we did. First of all, because we're Cisco, we got requirements from many different environments. People telling us, this is my pain point, this is my pain point, this is my pain point. And then we saw, okay, these are the fundamental things that we have to address when it comes to this emerging architecture. We have customers. I'll actually scroll through all of them because I never do well with animated slides. You have research academia, and this is par excellence, the OpenFlow nirvana. They want to actually have OpenFlow and play around with new control algorithms, and people are doing master's thesis and PhDs through the wazoo working on top of OpenFlow. In fact, it is that way because when you have discussions with academia about OpenFlow cannot do this, there's always someone that says, like, I can do it. I'm doing my PhD on that. I'll be finished in 5 years. It's like, yeah, then we'll raise it. Then you have massively scalable data centers, and there the main application is traffic steering, traffic awareness, and to derive network intelligence as well. It's massive in scale, but traffic steering is pretty simple in scope, which is why there's some use cases there from huge companies. We'll not mention any names because I'm being taped, and I don't think we're allowed to. But yeah, it's a typical use case as well in the data center for simple traffic steering in the data center and across the wide area as well. We talked about the cloud. When it comes to multi-tenancy, it's about orchestration. It's about OpenStack and similar frameworks. It's about automation of that configuration as well to make things far more manageable going forward. Service providers always ask for the same thing, always have the same priority. I want to monetize new services. I want to be more agile. I want to be reliable, but I want to be able to turn on the dime and offer people services on the fly. We'll have an example late in the presentation on how they can do that with these new mechanisms we're offering them. And finally, you have the enterprise, where the requirements are so different, varied, because everybody simply is trying to cater to the needs of their own business and their own business model. So the enterprise, I think the pattern is support whatever innovative application environments are there. Support whatever the business goals of the enterprise are. I think that's a big potential of SDN in the enterprise, to finally tie the network more effectively to applications and thereby to the business process. Because we all know that it's the application that touches a business process, and thus the application people typically are the ones that set strategies in IT. So all of these we cater to. Hence, we believe that you need far more than just like a control plane, a forwarding plane, OpenFlow in between, and say like, let's reinvent everything. We don't think it's practical. It doesn't solve anyone's problem. It's cool. The potential is awesome. It's cool like a laser ray gun is cool, but I'd rather take a Magnum to fight because I know that works. So we actually believe that you have to complete the puzzle. You have to really look at what are all the layers I have to address. We believe you need multiple layers of abstraction to actually fulfill the vision of the founding fathers of SDN, who talked about abstraction quite a bit. We believe you have to enable that application developer environment. And we've been talking about enriching the application environment for a long time. There have been several starts in Cisco where it's like, finally now we're going to offer network capabilities to the application, and we know we're going to consume them. We publish a new API that's 350 pages, there's some obscure calls in there, and not everybody adopts it. There's always some corner cases, but it's not like everybody adopts it in the end. So the open network environment does this. It spans all these layers. It creates different layers of abstraction to truly deliver on a number of problems that exist for networking out there, and to make sure that finally, that's a big hope, we tie to that application layer far more effectively, and that we become application intelligent, and in turn, we give the applications the tools to become network intelligent wherever it truly benefits them for business reasons or performance reasons. That's number one. What do we do about the control plane? There's always this fight between, oh, you hate SDN, Cisco, because you still believe in integrated control planes, and that's where your business is, so we don't believe it when you say that you are implementing OpenFlow and you're moving to that kind of architecture. Well, let them not believe it, but the fact of the matter is the model that we really advance is a model that solves issues in the real world here and now, that gives you the benefits of both. So with this, you can reinvent things wherever it benefits your business. With this, you deliver on the reliability, on the fairness that your users have become accustomed to. Why not combine the two? Why not actually have a control plane and a data plane? You maintain the network intelligence that allows you to operate every day the way you're used to, but you go and you complete it with another interface to another control plane, and here you can go to town and experiment. And you can slice them up and make sure that they are isolated, so you can actually deliver on new capabilities in the slice of your network and protect your normal traffic. So you can tackle new use cases far more effectively. So this is our vision for the network as it evolves. Also, if you go and just believe in this, this works if you're a greenfield, if you're a university building a lab. If you're building an enterprise network, there are many things you cannot do right now with SDN. The model, the potential is enormous, but in 4 or 5, it'll take a while for the ecosystem of control software to be there. So this allows you to get started and to maintain the basic design attributes that you like about your network right now. This is the way we represent the Cisco Open Network environment. Not surprisingly, it has in there the 3 elements that I talked to early on. So this is you could call this a canonical SDN definition, where you have controllers of agents and agents talking to a controller with, talking to a controller using OpenFlow. We support it. It's part of our strategy when it comes to SDN. Everybody has it, so we have to have it as well. Then you have here on the right virtual overlays with the Nexus 1000V, which is probably a fantastic and very powerful virtual overlay solution. It's quite unique in the industry at this point in time, supporting several hypervisors and many capabilities that are very open, very extensible. Of course, on the Nexus 1000V, the orchestration capability is particularly important. We provide the plugin to OpenStack as well. As well, we provide an API there. Multi-layered APIs, programmatic APIs. Did anyone go to the SDN session this morning where David Ward was talking about it? Yeah, that's center to our strategy. And I think it's also key to delivering on the benefits that people expect from SDN, to deliver on this application agility everybody expects from us. And we'll talk now a bit more about multi-layered APIs. That's near and dear to my heart because I work on onePK, on this interface down here. We believe they have to be multi-layered because different types of programmers need different types of abstractions. I presented early on what OpenFlow does, where a switch just establishes from one port, connectivity from one port to the next. Well, that's an abstraction, but it's so basic that I don't think an application programmer, like 3 layers above, really wants to discover network topologies and establish his own connectivity across the network. I'm sure that what he would want is a more reusable application sitting in the controller that simply is a RESTful call, where he has like a couple of possible target destinations, and he makes a web call and is like, hey, establish connectivity to this particular destination. That works, so you need different levels of abstraction. Here you need network device layer abstractions that abstract network device capabilities. Here you need network-wide abstractions that give you end-to-end primitives, very reusable primitives, end-to-end across the network, not just in the device, not just local, but across the network. That's a model we're working on. The controller sits here, the network device sits here. At this layer, we support OpenFlow and onePK because they complement each other, and we'll take a look at that in an example. And on top of that, on top of the controller, it's mostly about major abstractions, so it's RESTful APIs, it's web calls, eminently reusable. I prefer the next slide to talk about onePK. What is onePK? It's a complicated slide, but you will see it's an abstraction layer primarily that sits on top of all of our network operating systems, on top of iOS, NXOS, iOS XR. You could think about it like a Java virtual machine that we have developed for all of our network operating systems. And then you can write a program using an SDK, which is free, it's available, you can download it, you can start writing programs right now. And those programs, you compile, and then you decide where you want them to run. They can run on a process, on the router itself or switch itself. They can run on an embedded blade, so that's the UCS-E on the ISR family, or they can run on a dedicated or virtualized server, totally outside. And the application, the onePK application, communicates with the device it controls via a secure channel. Much like OpenFlow, which also communicates with a secure channel. What is it that I can do with onePK? What are the things that we have abstracted with this SDK? First of all, let's talk about languages. You can write Java, you can write C, you can write Python. That's what I'm going for. And you can do RESTful calls as well. Yesterday, someone said, justifiably, it's like, RESTful is not a language. It's an abstraction, and it's true. Basically, you use the other languages to create a RESTful abstraction, and that you make reusable for other people to build into their web apps. Everybody knows how to make a RESTful call. It's like clicking on a web link. The capabilities that we expose, some of them are quite basic, element capabilities, network capabilities. You discover the capabilities of network elements. You can discover topologies and read it. It's more or less of a read, of a pull model from the network. Utilities as well. You can subscribe to syslog events and queries. But here, this is where it gets interesting. When it comes to the data path, the policy, and the routing service set, you can do very powerful stuff with that. With the data path set, you can actually go and take packets out. You can inject packets. You can actually analyze packets. You can basically match stuff. You can nearly do deep packet inspection depending on the capabilities of the product. With policy, you can override policies all you want, create new policies, invoke them. And with routing, this is something that our new developers are using quite a bit. With routing, you can read routes, but you can add application routes. You can create new routes that are there and override the routes that trustworthy EIGRP has put in there. So you can tell EIGRP, you don't know best. I know best. For this application, use this route. For this case, use this route. People often, then the next question is like, but wow, I can break stuff with this. And it's like, absolutely you can. It's like, we give you the hammer. You can break your finger if you want. So you better know what you're doing. Of course, we provide a vast array of debugging tools. We provide a totally virtualized simulation environment for the software as well, where you have like an environment of virtual routers. Yes, please.
How secure is this, assuming somebody can craft that amount of code and inject it to a network?
It's as secure as we can make it for now, which is quite a bit secure. What you can do, there are things you can do. First of all, security is often about best practices. We all know that. But what we can do as well is limit the resources that you allocate to onePK applications so that you don't expose everything in your network to it. You can totally say like, hey, I want to limit this to, it can only consume like 5% of CPU and I can only do these capabilities. And we're creating right now access rights at a very fast pace where different people, you have to be very authenticated to be able to invoke certain capabilities, especially, and you can create the assignment yourself. You yourself as a user can say like, I don't want anyone to be able to do anything with the routing service set, for instance. Applications need to be authenticated as well. So they need to have certificate, things like that. So the usual, I would say. Safe as you can make it right now. But we're creating a more multi-layered approach as well to access rights to onePK within the router. Good question. So yeah, you can do a lot of stuff with onePK. Among the things you can do with onePK, among the applications that we have written, OpenFlow. We have an OpenFlow agent. It's been written on top of onePK. So we're not against OpenFlow. We're rolling out very aggressively. We're rolling it out on top of onePK. And this also illustrates a big advantage that onePK provides to us, quite selfishly. onePK actually was not developed to target SDN. It just conveniently emerged at the same time. onePK was once called Connected Apps. It was a project that started 6 years ago. Because quite selfishly, what we wanted is we wanted an abstraction layer so we can write features and drop them on top of all of our OSs and make them consistent across product lines, which we haven't always been great at, as you might know in the audience, but now we will do it with onePK. It's also a great benefit to us in our own development. We write the OpenFlow agent once, we're lazy, and then we can drop it on every product, and it'll always be very consistent. It'll be exactly the same user experience using the OpenFlow agent. Very exciting, X and C controller as well. We have a controller. It's called it was named the Extensible Network Controller. Was it this week, Omar? Yeah, absolutely. And we're showing it in the world of solutions as well. You can see it in action, providing some cool functionality. It's written in Java. Hence, it's no surprise that it can communicate in Java. But a lot of the calls will be RESTful. The API is public under a framework that I'll talk about in the next slide. It reflects our philosophy in the open network environment of being extremely extensible, of catering to many needs. So it's not just write your own application environment and we support only OpenFlow. For obvious reasons, we also support onePK going south. I'll provide an example of a potential benefit that provides you with. It's a shortcut to basically invoke some functionality that OpenFlow cannot do quite now. And there are more coming. I mentioned a couple of random protocols such as I2RS or PCE. They'll all be invoked from here as well. So very modular architecture, extremely extensible, has created a lot of buzz in the market, so much so that who has heard about Open Daylight? Wow, good number of people. Open Daylight is where we actually got together with other companies. We decided, you know what, the market actually needs a joint controller. And the guts, you could say, the innards of the extensible network controller, we're taking as a basis for a project under the Linux Foundation. And now you have a bunch of companies building on top of that, building that missing controller software infrastructure and working with common goals to actually go and complete the framework for SDN. It's to advance the cause of SDN in the industry. The companies that joined, wow, see, there's IBM there. There's companies you wouldn't expect to join and work together with Cisco. You have Juniper, you have Brocade, you have Huawei. Lots of companies joined. It's a fun project. You can download the SDK and the software right now and play with it. And you can monetize it too. Very important aspect of this. If you actually decide with onePK or with the XNC that you have something very special, that you have an application that can benefit the market, if you decide that you have an OpenFlow agent that's better than ours, you can actually put it on the Cisco application marketplace, and we'll monetize it together with you, of course, but you'll make money of it. So let's talk about an example. I told you 45 minutes. It's going to be nearly the case. Let's see how it all comes together and why it makes sense to actually combine OpenFlow with onePK to get a shortcut when it comes to time to market on certain applications. I changed this a little bit to have a different storyline. Imagine it's me on a Friday night. I get home, 7 p.m., and what I like to do is get a glass of wine, a Barolo preferably, and watch a movie in HD. So I go to my favorite streaming content provider. I turn on the movie, and lo and behold, even though I'm in HD, because 5 million people are doing exactly the same thing. I think that on Friday nights, Netflix and Amazon amount to about 50% of internet traffic, I read somewhere. Then all of a sudden, those famous 4 little bullets, they recede, and I'm just watching my movie with the quality of 1. It gets fuzzy. I'm frustrated. I would get angry. So what if some entrepreneurial spirit in the streaming content company would approach a service provider and say, like, let's work together on this. I know you have something like called onePK. I know you have an OpenFlow-enabled switch in there, infrastructure in there. Why don't you offer me a RESTful call that I can bind into a new service? So instead of just having standard definition on that web page, having a standard definition option to watch the movie, a high definition, I have a third one that's high definition with guaranteed delivery. And it's $3 extra, and the service provider and the content provider split the money. How can this be done? It can be done. We actually already provide the hooks to do that. So you have the Cisco extensible controller there. You have onePK. You have any of our operating systems. I say onePK here, but honestly, it could be a third-party switch because the last part of the example will be OpenFlow-based. So the network manager uses XNC to discover the network topology. So the XNC now knows exactly this is the topology. The next step is the ISV, the content provider, now develops an application that subscribes to a service that the service provider offers on top of the controller. And the service is preferred delivery. And it's a RESTful call. So they can bind it very easily into their web page when it comes to the content. And now I start watching the movie, which is very latency and packet loss density. And now something happens somewhere where it slows down the traffic. And don't know if you saw it in the animation, because there's a congestion. And just as I'm about to spit out my wine, lo and behold, the XNC uses OpenFlow to reconfigure the path across the network, goes for an uncongested link. Very easy, very straightforward, eminently doable. In fact, we're showing it in the demo booth. We're showing something called latency-based routing, which is exactly this. And where you implement the routing, basically, you could actually cater to any business need with the routing. Told you 45 minutes. It's 40. We'll be done soon. I'll just wrap it up, I think. What are the top 5 takeaways here? As you can see, and I think this first bullet is very important, where it's like OpenFlow, SDN is not all about OpenFlow. SDN is about an architectural model that decomposes the existing router, control plane, forwarding plane, and OpenFlow is one of the protocols that you can use to fulfill that model. Has a lot of momentum behind it, will be around for a while, I'm sure. But as you can see, even with SDN, if you have that separation at the controller layer, you don't have the software infrastructure yet. You have a lot of projects going on, but there are not many real business issues you can tackle right now, and that's where the open network environment comes in. We want actually to be actionable. We want to target business issues, and we want to make money too, of course, in the process. No one will buy anything from us that doesn't extend their network with a capability that is valid at the business layer. Yes, we have a broadest approach to network programmability, very important going forward. As network engineers is an area that you should start following programmability. It's going to be a very marketable skill to have going forward as a network engineer, because you'll play a key role in exposing network functionality towards the application guys going forward. And when that happens, when you have that kind of exchange going on between different teams, that's when innovation happens. We don't know what will happen with a lot of this. We in Cisco will be abstracting functions, we'll be offering the predictable abstractions to you, but ultimately it will be out there. The software developers, it will be you that creates based on your business needs, you will create the exciting applications as it all comes together. And that's I think that's a real promise of SDN. Questions, comments, experiences anyone wants to share? Someone was playing with OpenFlow. I'd love to hear what you're doing. All right. Yes, please. Yes, it is. Ruby, not yet, but we talk a lot about it, so it will happen, I think. Yeah. Yes, please.
Speaking of Python and Ruby, when you talk about programmability, putting that in our skill set, I got into networking because I didn't do well in my job sometimes, right? I got into networking because I'm not good at that. So how do I accept that I have to take that on. How do I even go about starting? I have no idea where to start.
You saw it this morning as well, the long discussion about that. There are my programming is very rusty. So there are lots of resources online to start with the beginner's classes in programming. And then I'd say approach your manager with a small project of something you can do very simply to automate the task in the network, where instead of using a script, you use a simple Java program or a Python program.
You might even look at starting with things like Chef and Puppet, first of all, to just get a feel. Also look at an easy language, whatever works for you, just because the big hurdle is learning the fundamentals of programming, not a particular language. I think once you get those things down, then you can adapt to whatever language suits your purpose or whatever.
Yeah. Python is very nice. It's easy to learn, really.
There's still so much networking. It's intimidating.
It's you and all of us. Yes, please.
Now, another question about Python. Python is an interpreted language, and it's script, basically scripting that's interpreted. Where does that Python program live within the context of onePK? Is it on the controller? Is it on the device? Where's that in the script, the Python script?
You pick it. You compile it, basically, and then the application itself can run anywhere.
All right.
Yeah.
Anywhere, whether it's controller
Yeah.
or the switch.
So the connection between a controller and is an agent something that runs on your device? A onePK agent? How is the controller connected to your device? It's just like SSL SOAP calls?
Yeah, it's a secure communications channel defined in the OpenFlow spec.
It's like an API.
Yeah.
So what is an agent and what is a controller?
The controller is the software that communicates with the agent which resides on the switch or the router. Yeah. Yes, please.
There was a slide where you showed OpenFlow and onePK. Does OpenFlow talk to onePK, or is it? This might be an arbitrary question, but does OpenFlow sit on top of onePK or vice versa? How do they interact?
You develop it on top of onePK, but then the OpenFlow agent pretty much has pretty direct access to the underlying infrastructure. And it's a controller that can talk to both onePK and the OpenFlow. It's the easiest way to look at it.
So isn't that more either or, not and, right? So you could use OpenFlow to communicate control to the device or onePK.
No, it can.
It can do both.
You can run concurrent conversations. So OpenFlow, so
OnePK,
onePK,
yes.
so onePK is a horizontal layer. It's integrated with the OS. It's got a pluggable architecture, so it can plug in different, expose different protocols. So OpenFlow now could be netconf, could be BGP,
Yeah.
architecture's compatible. So in both cases, when we talk about onePK, we can have a pluggable architecture. Depending on the controller you're using on top, it can talk multiple protocols at the same time, and that's really what we expect to evolve. Is there are different protocols that come out for different purposes. So you can have, depending on how you write your application, what you're asking it to do, if you want to convert conversations running multiple protocols to the same piece of hardware, but as a programmer, you don't want to do that. Straight.
Yes, please.
So what are Cisco's plans in terms of like open support? Is there a plan to have like a forum or a community that's sponsored by Cisco to help promote individual contributors outside of Cisco and help proliferate what type of applications can be?
100% and enthusiastically, yes. We want a thriving community out there. There are like, within the onePK developer community, there are like GitHub communities. We try to make it a very thriving environment. I hope that by the next Cisco Live, there'll be like a dedicated event or party for onePK developers. And the same thing is happening with Open Daylight as well. Yes, please.
What hardware today can you prototype with onePK? Is it 3750X? I know last year there was some talk about that. Or what can you control?
Let's see. Wow. Now you're asking me the roadmap question, and I have like a terrible memory for roadmaps. But right now the availability of onePK is, let's see, Nexus 3000 for sure, ASR 1000, ISR G2. I know there are more.
I have it here. Q3, ASR 1K, Nexus 3K. Q4 is ISR, N5K, N6K, N7K. Q1 2014 is CAT 2K, 3K, 4K, ASR 9K.
All right. And wasn't that NDA? Yes, please.
Question about the OpenFlow protocol. Is there a protocol between the controller and the router switch?
Yes, that's,
Changing messages between
That is OpenFlow.
yeah, that is OpenFlow.
The protocol between the controller and that's what
Yeah.
protocol does.
OpenFlow is, yeah, it is not a transport protocol. It is merely an exchange of information between the controller and the switch.
Signal, you can just define what message is, the message format, and how to change that.
Yeah, basically it's control code to program that you can.
And so the API you provide is one way to implement that, correct?
It's one that takes the signaling protocol and translates it to something the switch can do something. Right. So at some point, if you have an OpenFlow call, at some point that needs to be translated into something the switch understands in terms of drop this MAC address or route this MAC address.
So let's say a Juniper switch or router also want to implement OpenFlow, so they have their own. There are different APIs.
Yeah, when you buy OpenFlow firmware for Cisco switch, HP switch, Juniper switch, that's what it does. It takes the OpenFlow protocol and then translates it into something that the switch, the native switch silicon will understand what to do with.
All right. Well, I have some hats here about everything is programmable, that your special collector's edition as well. And I also urge you to take a look at the World of Solutions at our Open Network Environment demos as well. And please, there was another question there.
Yeah, I mean, I guess it's kind of on the same lines as he asked. So, I mean, you write all this code in this language, Java, or like, different languages. What is finally pushed onto the switch? Is it still a configuration script in iOS, which is running today, or what kind of config is pushed onto the switch?
No, it's an onePK application, and it can reside on the switch. It doesn't have to. It can also reside somewhere else and communicates with the switch